about a nice big round of applause for Daniel Wittenberg?
So we'll talk about some of the things I've learned over the last year or so of Nagios 4. Some basic stuff about me. I've been using Nagios for, I don't know, forever it seems. Did a consulting business for quite a while that we did a lot of distributed Nagios nodes, so learned a lot then about, this is probably 2.x era when we started that. Was working for Fortune 50 insurance company last year, kind of changed jobs, so we did a weird stuff between. Company I work for now, we do kind of a managed service provider. So monitoring is a small piece of our entire platform, but this part of it still runs off Nagios, so that was the reason why they wanted me to come take care of it for them. So last year was where I worked. Couldn't say where I worked. Still not supposed to, but so the only real point of this was that there'll be some stuff, because I've only been at the new job for about 5 months, so there's a lot of stuff I learned at the last one, because we already had about 12,000 devices monitored with Nagios 4 in production. So learned quite a bit about that. That's where we did a lot of the initial Nagios 4 performance testing. We had some big giant VMs that we could throw all sorts of giant configs at it and see where it would fall over. And so I'll kind of flip a little bit back and forth about some of the lessons we've learned in both places. So currently, got about 700 Nagios servers, 130-ish thousand, about 3 million service checks. A lot of it is still 323. I was kind of hoping it would be more 4.0 by now, but you'll see one of the architecture slides later, and there's a lot of moving pieces, so it takes a lot longer to kind of QA everything and get it working. But we've kind of stuck with scientific Linux. A lot of the 323 stuff is on 6.2. We're going to 6.4 for the new one, all latest stuff. The OSs are all managed by Puppet, so I want all of them to be pretty much exactly the same wherever possible. So my general philosophy with Nagios servers is they should be dumb and stupid, and I can throw them away and put another one in its place and just keep going if I need to. About 2/3 of what we have is on ESX. There's still some bare metal ones that are out there that there's some clients that refuse to give up bare metal, and some of them just haven't been migrated in a while, so until the hardware gets really old and unusable, it'll still be there. We're adding a ton of Nagios servers. My official duty is within R&D, but I own the monitoring platform, so we have a deployment team that actually deploys all the new stuff, and so I see them updating and deploying new Nagios servers all the time, and I really don't know what some of them are for, but okay. So what's different with 4? Speed. That is the biggest thing that has helped for large installs. I'll show some test results in a minute, but on average, depending on how many cores you have, we've seen anywhere from 700 to 500% faster. A lot more service checks, just a lot more efficient in general. Restart times are just insanely fast now. Even on the largest configs we could possibly put together, it was less than 2 minutes to run the full verification and startup. So, so some of the stuff that is coming in 4, or that came in 4, a lot of these Eric already covered, but these are some that you used to kind of watch out for when you're looking at performance stuff. So I just kind of wanted a quick cover. Embedded Perl, yeah, more of a stability issue. Used to cause a lot of weird issues, so I used to try to get rid of it anywhere possible. The external command buffer slots, yeah, one thing you always had to play with, add some more, keep adding more and more and more until it finally didn't blow up, and then, you know, stuff it into cacti and watch it again for a while. And so that's just nice, not even having to even look at that anymore. The -X option to watch circular paths, yeah, that made the startup times a bazillion times faster. Not having to do all the verifications and everything, it all just works now, so we can get rid of all the special stuff and just start it up and run. Configuration, the verification stuff, yeah, that's been another huge option for startup. That's probably where we got the most most amount of changes, especially if you're in the large installs where you tend to add and change stuff a lot. Having to restart all the time or reload is kind of a pain. So that pretty much makes it a non-issue. The algorithm changes. Andreas has a good layout in his presentation from last year. We went through a lot of that, has a lot of the different detailed info. So if you want to know more about how that actually works, I'd see his presentation. And disk I/O reduced to virtually zero. This is really, really helpful when you're on VM systems. I always had a big issue with trying to set up RAM disks and do everything you could to shuffle things around, and that's just all gone too now. So it's you don't have to deal with it. I think I still use some of the object cache stuff, but the impact is almost nothing now. So that's pretty nice. The check results, I think, was probably the biggest hit that we saw. There was just so much little writing going on that VMware had a hard time with it sometimes. Query handler is really nice. I really love it for being able to kind of almost think of like turning on debug without actually having to turn on debug. So if I want to know if stuff is actually executing, just connect to the query handler and watch what things are going on. I also use it a lot for watching kind of what the job status is, so you can see what job, the max min, how it's performing. The new core workers, huge benefit. That was one of the big problems we had with VMware too, was that the continual forking was so heavy that it would hurt VMware a lot. That really alone made VMware a very, very viable option for 4.0. Where 3.2.3, you could easily make the case that it had to be on bare metal if you were going to large setups. And the spec file, we did a lot of work when we were doing a lot of the initial debugging. We added in a lot of the stuff into the compile time options for the spec file, so you'll get a lot better debugging if you use the RPMs. Which, I don't know, I guess we haven't really used it a lot, but it was when things were blowing up about every other day. It came in handy having all the debug stuff in. So some of the testing that I did was all on ESX5. All the stuff was on the same cluster. Changed the different CPU cores, but pretty much stuck with 4 gigs of memory. Memory really has never seemed to be a problem. Works pretty well. So some things that I watched, I have some automated testing that goes on, and these are some of the specs that I watched to see, is the server still, quote, healthy? So watching the CPU block queue, making sure things aren't piling up, making sure I'm not hitting I/O wait time for some reason. CPU idle, watching your check latencies, host latencies. A lot of those are actually driven by, I noticed, by external things happening. Sometimes checks that are a little bit heavy. Other things you might have running on the system, like Puppet, if it detects it needs to update a package or something, sometimes will cause outside stuff. So I was kind of watching those, not necessarily because Nagios would cause problems for itself, but just because the OS is running and doing all of its normal maintenance stuff. So then I had it run basically a 30-minute polling time. So it would run these scripts, and every 30 minutes it would look to see where it's at. And if it had generated 3% failure rate, it would fail the test and stop the automated testing. And that's kind of where I got my numbers from. So the numbers you could actually push higher and the system wouldn't be dead. But these were kind of what I used to judge, is it still healthy in a semi-usable server and still kind of doing what it needs to do. What I would kind of look for if I was watching for problems on a production environment. So that's kind of where I tried to base my tests at. Yeah, so fully automated, increasing the workload. What it would actually do is I've got some scripts that will generate fake hosts and services. So every 30 minutes it would run, and if it had successfully ran with no errors or less than 3%, it would actually generate some more hosts and kick it off again. And it'd keep doing that until eventually it would fall over. Yeah, so it just kept adding a host and a service. So basically just a one-to-one. It would add one host with one service. So it was really easy to kind of watch the numbers as it would grow. Nothing too complicated. I think the service check did the equivalent of like an NRPE version check against a remote host. So it did one remote check, so you had some latency there. And I did play with a while too. I put some IP tables rules in to actually slow down the checks, so it was more Because when they're on the same VM, it's like instantaneous. So it doesn't really work so well. So I had to put in some latency to make it actually more real. So this is kind of what I did for my test case. I had 2 different boxes on 2 different clusters. And then I had a whole series. I think there was 4. I think in general I usually had 4 different test nodes. And I'd run them independent, so I wasn't beaten on the same 4 hosts. But those 4 hosts, in the end, would sometimes look like 20,000. So they really got pounded into the ground, and they were in pretty bad shape by the time I got done. But so yeah, I just kind of kept round robining the names and addresses around to make them look like a whole bunch more servers. So some of the test results against the 323, and then I think it was RC1 is where I did the test, but I don't think there's been a lot of real performance stuff change in a while. I think the performance has been pretty standard. Yeah, it hasn't been a whole lot changed. So, so as you can see, this is one of the things that I wanted to spend some more time on. Was I noticed that as I added more cores, the percentage of difference got less, which was interesting because I always had more problems with higher cores on 323 before. So I was hoping to go back and kind of spend some more time with some of this, but I don't always get time to just play for days on end with this kind of stuff. But so it was kind of interesting to see the number differences. So other stuff that we've got, we kind of made a customized version of live status based on Andreas's fork of it, just because we've got a lot of kind of custom changes to core. I think most of them probably made it back into core that we did, but there's a few kind of weird IPsoft specific things that are in our version. So yeah, we're developing a new single pane of interface, kind of like a multi-site, but not really, because I don't need a lot of the, I don't want a lot of people to have the same features. I want less features than multi-site has. People can do too much. I don't want them to have that kind of power. We've also developed a mostly working REST API that talks to query handler and live status. It's still kind of a work in progress. There's a Nagios QH. I think Eric said that got posted somewhere. Okay. And it was just a simple Ruby script that I wrote that's kind of like a shell interface sort of to the query handlers. You can connect to it, do a help list, run a lot of the commands, and it kind of helps walk you through running the different stuff. So it's a little easier to kind of be able to get in and start playing with the query handler. One of my other projects I started working on, is not completely done, is this custom load control daemon. I'll probably try to publish it once it actually works a little better, but it uses some of the new stuff in the query handler to kind of watch the OS load and what's going on with it, and will dynamically adjust how many jobs you have running through the query handler. So if your system starts to get overwhelmed for whatever reason, like I've seen it happen on certain checks, like if you're doing a lot of SNMP checks and all of a sudden the devices stop responding, like especially some of these really large Cisco catalysts that they figure SNMP is one of the things they don't care about. So if you try to query them and they're busy, they'll just ignore you. So some of those start piling up, and then your system will start to go into the ground. And so what this does is it kind of watches OS metrics, and then will automatically adjust the load that Nagios is doing and kind of back it off until it gets a little more under control. So hopefully you don't have servers that just spike CPU out of control. Because that's one, I guess, sort of bad thing about 4.0 is it's so efficient. It can run itself into the ground pretty fast. And another project I was working on was an event broker to send like perf data directly to ActiveMQ. So I don't want it writing files, keep reducing that disk I/O. So just send it off to ActiveMQ, and then something else pulls it out of the queue and does its processing. And the other thing we have is a custom agent that's kind of like NRPE, but was written a long time ago before there was really many other alternatives. But you can do like auto updating in place as one communication channel, sends all of its config files, all the custom checks go down that path. So it's kind of a two-way streak. It does log stuff, but it's kind of does everything sort of agent. Some of the other performance tweaks that I've done, I did notice that with 4.0 that there was a lot more network traffic because it was so much more efficient. It could push a lot of checks out there. So I had to kind of adjust some of the TCP settings to make it a little more efficient, because I would notice that like a lot of stuff was piling up in time wait. I was getting like thousands of stuff in time wait. So kind of had to play with the TCP settings a little bit. The RAM disk, yeah, it was in the RC script. We put it in, well, I think when we initially started doing 4.0, I put it in there because we were still using the RAM disk under 3, but it's one of those things that will probably go away in the next update to the spec file. So yeah, keeping logging levels as low as possible. That will still hurt it. If you run in debug mode, you can definitely hurt the performance. CGIs are still another point that if you use them a lot, will still hurt the system. Try to use them as least as possible. The environment macros, they still can hurt the system on a large install, so I try to disable them whenever possible. And the resource macros did get a lot better. Eric talked a little bit about that and all the changes for it. I try to still not use them as much as possible. I know we've talked about some ways to do some caching with them, but when you've got a lot of those being evaluated continuously all the time, it's one of those things that can eat away at some of the CPU. So I try not to use them as much as possible. And in our case, you'll see a little bit later that we've got basically a templating engine that builds our configs, so we can just not build that in. So, oh yeah, and because it can run so many more things now, we had to up some of the limit settings. And also noticed that on some cases, the out-of-memory killer, we found that some people that would run like really heavy checks that would take up a lot of memory, that it would drive itself into the ground. And it seemed like one of the first things it liked to kill was Nagios. That's like the last thing I wanted to kill. Kill off all the other checks and kill off anything else, but leave my Nagios alone. So I tend to put it in there to tell it to try to kill that the last as possible. And Puppet. Puppet, while it's great, tends to kind of beat your CPU up a bit when it runs. So I always put in etc sysconfig Puppet, change the nice level down so it keeps it a little bit less priority and doesn't hurt it as much now. Kind of done the same thing to other services that I've noticed that have kind of spiked up. So some of our add-on stuff that we run that do other maintenance kind of stuff, we kind of went in and changed all their nice levels to run lower, so that way you just can't hurt it as much as possible. Some of the perf tools, a lot of the kind of standard stuff to watch. But a lot of people will always ask, well, what do you do for watching CPU and memory? And nothing really rocket science, just kind of a lot of it is actually just watching a VM stat and IO stat and just kind of watching what's happening while it runs. So some of the things that we've done to try to keep everything running as good as possible. I like to monitor everything. I want to know everything about the box as possible. Collect every metric possible. You know, the CPU load and the CPU stats, where is it spending its time? So when things happen in the middle of the night and you're not watching it, you know, did the IO wait go through the roof for a minute and then stop, or you know, whatever. Disk space in the inodes. We actually had the inode one creep up. Puppet did something weird and generated a bunch of little tiny empty files in a directory, and you do a df and it says it's fine, but it can't create files because it's full. So yeah, watching all the logs, obviously hardware status if you're still on physical. Memory usage, which has always been really good, but I still tend to kind of watch it for those rare cases. Also watching the Puppet state file, watching that to make sure it's been updated in the last few hours, because if it hasn't, then something's not right. Apache stats, we're still watching because the API right now still runs through that. And if you're still using the CGIs, obviously it's nice to have that. Network performance, yeah, I watched that. I started watching that a little bit more closely with 4.0 just because it's so much more efficient. It's doing that much more work, so I tend to watch that a little bit more. And NTP time and drift. I've seen issues in a lot of VMs in weird cases where the NTP time gets off, and then like weird things start to happen, and like the scheduler sometimes gets confused when your time like changes. I don't know if you've ever seen that too, but it's It's usually when the time starts to get off, and it seems to be a somewhat known issue with VMware, but there's some tweaks I probably should have put in here that you can do that will help it out that VMware recommends, but that's one that can just cause some just kind of bizarre problems when it gets too far off. So yeah, one of the questions I always get is, well, how do you do X? How do you do, how do you generate configs, and how do you manage all of this? So this is a still fairly high level overview of what our architecture looks like. So it kind of starts off with either an API or somebody sitting at a console that adds new servers into a CMDB. Then this discovery process goes out and finds out what it is you have, blah, 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 dumps that right back into the CMDB, which then goes out, has this template engine which understands which version of Nagios you're on and will build templates accordingly. So it pushes a bunch of stuff in and out of CMDB. Then it will actually contact however many Nagios servers you have and just start spreading load out, which then goes off, actually does all the monitoring. Then it comes back and dumps it, which this right now is active MQ. So that's why we push a lot of stuff there, 'cause it's a nice kind of buffer. Then we actually take a lot of our external data and performance stuff and dump it into a big giant Cassandra cluster. That's something like 4 million data points a second or something crazy. So that's when we then start to run some of these kind of third-party, well, not third-party stuff, but kind of the extra tools, the anomaly detection, capacity planning, predictive analysis, and those can actually go back and generate alerts too if they start to see like weird anomalies happening that may not be within your thresholds. So we're still doing a lot of threshold stuff, but we're kind of moving away from having kind of static thresholds on a lot of our stuff to doing more of dynamic anomaly detection stuff. Just because when you start to get at a certain scale, trying to manage thresholds for this disk on this server and this disk on that server and CPU over there, and when you get hundreds of thousands of servers, it gets kind of out of control. Some kind of known issues that I've seen and some, I guess, personal complaints. I've seen the number of workers on the smaller systems, mostly during testing, can easily overload itself. It's usually like only on the 1 or 2 core systems where if you throw a whole lot of stuff at it, it will drive itself into the ground pretty fast. So I've got a kind of a patch on mine that will let me set the minimum number of workers down lower, and it gives me just a little more control over what I do. But for the most part, that's usually just during testing. Most people I know don't usually run that small of a VM on production stuff. The remote workers would be nice to have. I know it's coming probably at some point, but that would be nice in certain cases. One of the things that I found, and kind of along that lines too, is in most cases now, if you're running VMs, it's almost easier just to spin another VM up than to try to spin a host up just for like a Gearman or something. Just kind of my personal experience. So in a lot of cases, I don't know that I would use remote workers for a lot of it, but I think they would help offload, especially when you have specialized stuff like SNMP checks tend to be very heavy. It would be kind of nice to offload those to a box dedicated to doing that. We have some pretty large customers that have lots and lots of SNMP. Also VMware. If you're using VMware's Perl SDK, tends to be rather heavy. So if you're doing a lot of like ESX monitoring. So there's a few of those things I would kind of like to be able to push off somewhere else. One of the other things that would be nice to have when you get to this scale is when you start adding and removing hosts, having to restart all the time to do that. Granted, 4.0 made that almost non-trivial, but it's still kind of a pain if you're every 5 minutes restarting to add and remove hosts. I think it would also be nice to kind of see a REST API natively, but I said it's not too hard to add in if you've got live status, and especially the query handler now. And live status or some similar technology I think would be really nice to see natively. So I guess any questions? And one of the things I had noticed, I'll mention too, is that when I went back through my slides from last year, I started noticing that a lot of the pages were dedicated to hacks that you had to do to get it to work under scaling that just kind of went away now. I was like, well, we don't need that, we don't need that, we don't need that. That's irrelevant. So I was like, I lost like 5, 6 slides just from all that. So.
Are you saying that hupping the Nagios process doesn't work in your environment?
Doing what?
Hupping the Nagios process doesn't work in your environment? You said you had to restart it.
Doing reloads with 4.0 is different. You won't reload all your configs the same. So
Okay.
you actually have to restart to pick up all your changes.
Hi, you said you were doing. You said you were doing CPU monitoring. Are you doing it per core monitoring? The stats available for each core?
Not generally. Usually I just watch light load average in general and the CPU general stats. So which watches an aggregate of all the cores.
I've been watching of each core for Nagios server. It appears that the first core is much more overloaded, both on the 3.5 and 4, and still on 4.0. And I think a lot of this has to do with, it will depend on your installation, but a lot that has to do with I/O, basically I/O weight that happens for all the plugins.
Mm.
So that's why you probably did not see quite as much improvement by increasing number of cores. It's just common problem.
Yeah.
You have to offload it to different servers that would have less CPUs. If you have a remote server, like Gearman, I guess people use, you don't really need to have a lot of CPU cores for those remote servers.
Hmm.
Any additional questions?
So if I'm using a Gearman setup, what do you anticipate are some of the enhancements are to see or things I might be looking at changing?
Well, with Gearman, I mean, the big benefit you'll get with Gearman is the embedded Perl. So if you're doing a lot of Perl stuff, having that will help. Otherwise, I mean, you'll still see a huge performance increase with it, but I don't think you'll have any problems if it's specific to Gearman.
What about when you do have to update, is that update time significantly decreased on Core 4 now? I know if you got a larger installation, sometimes when you go to do those updates, for example, on one server I got about 12,000 hosts. That could take 15, 20 minutes sometimes.
Oh, to do like a restart with the verifies? Mm-hmm. Yeah, no, it'd probably be like a couple seconds. Yeah, like I said, I think the absolute worst configuration we could come up with was still less than 2 minutes. And that was like not a usable, the server couldn't actually do that much work, but it was as much as we could throw in a config file. So.
And I believe from the initial presentation, you're looking at sometime around January, incorporating 4 in the XI?
Well, I don't actually work for Nagios, so
you don't know.
I don't know, but I think that's what I heard too.
Could you expand a little bit on the reduced disk I/O improvements that we're using? Because you said that there was MEMFS was no longer required, but I'm guessing that your primary platform is Linux. And
yes.
There was like something in the RC script or something, but I work on FreeBSD systems, and it's absolutely imperative that I use memory-based file systems for that platform. And I'm just wondering, am I still going to have to use that, or what are the improvements? Are the traditional files still there, or are they just handled better?
Most of them just aren't there now.
Okay.
Because usually, I'm trying to remember now what all I put on the RAM disk. There was usually 3 things that got stuck on the RAM disk, like the check results. Check results are no longer there, so that's really a non-issue. And if you don't need a lot of the status files and stuff, you don't have to write those out. But yeah, the disk I/O is so much better now that it's really no impact to not use the RAM disk anymore.
Okay.
I've completely removed it from all of my systems just because it's one more moving, complicated piece that it's so much more efficient now, you just don't need it.
Okay, so those files are just all gone now?
Well, yeah, for the most part, yeah. Or you can turn them off if you don't need them. Like the new changes for dev null, you can actually send them into dev null and it won't even write them anymore. So.
Okay, thank you.
Mm-hmm.
Just a confirm the question earlier about Core 4 getting into XI. It is planned for the 2014 release, but we still have some testing. There's a lot of pieces, a lot of moving parts that we want to make sure are all going to function properly. But it is on the roadmap to be included in the 2014 release. Maybe late this year, beginning of next year possibly. So.
Any additional questions? One more time for Dan Wittenberg, ladies and gentlemen.